So starting with binomial, right? Binomial theorem. Why binomial theorem is used? What is the use of binomial theorem? So basically it is about finding out the values, finding out the terms in expansion of a bracket. In expansion of a bracket, and during that expansion, sometimes we will go with all the terms. Sometimes we go with like that, okay, what is the fifth term, any specific term with term number, or we go with any coefficient of a variable with some power. So these are the things which we solve by using binomial theorem. Okay. So first of all, what I'm going to do over here, for instance, you are having a plus b whole power 0. Okay, a plus b whole power 1, a plus b whole power 2, a plus b whole power 3. Okay, first of all, you have got this one. So when I will expand this thing, this will be a plus b whole power 0 will be equals to 1. Power 1, that will be a plus b. Power 2a square plus 2ab plus b square. Okay, a cube will be a cube plus 3a square b plus 3ab square plus b cube. Okay, these are the things which we will do when we are having expansion. Now the first thing you can see over here, power is 0, number of term is 1. Power is 1, number of terms are 2. Power is 2, number of terms are 3, and power is 3, number of terms are 4. So it means in an expansion, comma, number of terms will be equals to n plus 1. Okay, the number of terms which we have to get after expansion, that will always be equals to n plus 1. That is the first thing I am giving you over here. Okay. Now I have got an expansion over here of a plus b whole cube, which is a cube plus 3a square b plus b cube. Okay. Now inside the bracket, power is 1, whole power is 1. Okay. Outside the bracket, for each term, if you are going to add their powers, like what is the power over here? Power is 3. What is the power over here? A square and b power, then a power 1 b square and then b cube. All of them are sum up to 3. This is 3. 2 over here, 1 over here, add up to 3. 1 over here, 2 over here, add up to 3. And this is also going to be 3. So we can say that in this type of expansion, the total power over here will be equal to sum of these powers. But what is the important thing? First of all, inside the bracket, it should be 1 and 1. Only then you can do it. Okay, so it is not a general rule. It is just a small trick which I am telling you over here. Okay. So now, with the help of this example, now I am going to write a general formula over here. What is that general formula? The general formula of binomial theorem is TR plus 1 NCR A n minus R and b to the power R. Okay, this is my general formula. Now we are going to simplify it, and we are going to, now I'm going to explain you what is the each term expressing over here. Okay, first of all, n is expressing whole power on the bracket which is supposed to be expanded. Okay, in this case it is 3. N will represent whole power of the bracket which is to be expanded. Okay, first thing. Now A will represent first term in the bracket which has to be expanded. B represents second term of the bracket which has to be expanded. Okay. Now, what is the power of A right now? The power of A is written N minus R. And power of B is written R. If I add both of them, power of first term was N minus R, power of second term is R. If I will simplify them, so the result will be N minus R plus R. This will be cancelled. So the result will be equals to N minus R plus R. The result will be equals to N. And what was N? N was the whole power which I have told you over here. So in each term, if you will add the power of the given variable, it will mostly equals to the given whole power of the bracket. Okay, not in every case, but mostly it will happen. Okay. Now after this, I have explained you that n will always represent whole power. A is first term, B is second term. Okay, these things I have explained to you over here. Now let's write this thing over here and compare it with this one. This thing NCR, the combination thing that we will do when we are going to work out with unknown powers. Unknown whole powers is given. So let's write these things. A cube b power 0 or a square b power 1 or a b square or a to the power 0 b cube. Okay, they are written in a pattern. The first term is having descending powers and the second term is having ascending powers. See over here. The first term is having descending powers and the second term is having ascending powers. Now, let's compare it with this one. See, a n minus r b to the power r. So, okay, which term is this one? I haven't written my coefficient right now. I'm not talking about the coefficient. I'm just talking about the variables right now. So, this is my first term. Okay, this is my second term. And this is my third term. And this is my fourth term over here. Okay, this is my fourth term over here. Now, if I will compare it with this one, a n minus r b to the power r. See, what's b over here? B to the power 0. So it means in this term, the value of r is equals to 0 if I compare it with this thing. R equals to 0 because b to the power r is the part of the formula. So b to the power r and b to the power 0, it means r is equals to 0 in this one. Okay, let's talk about this one. I'm not talking about this one right now. I'm just talking about this thing. B to the power 1, b to the power r. It means r is 1 over here. In this one, r will be 2. In this one, r will be 3. Okay. When I'm comparing it with this one, I have written what will be the value of r for this term, for this term, for this term, and for this term. Okay, that I have written over here. Now, let's compare it with something else. First term, r will be 0. Second term r will be 1. Third term r will be 2. Fourth term r will be 3. What does it mean? It means the value of r will be always one number lesser than the term number. If first term, r will be taken as 0. If third term, r will be 2. If I am talking about fifth term, r will be 4. If I am talking about seventh term, r will be 6. In this same way, if I am saying the value of r is 8, what will be the term number? You will say, okay, 8 plus 1, term number will be 9. If I am saying r equals to 17, which term number? R plus 1, term number will be 18. So see, over here I have written what? For term, any term, it will be always R plus 1. Where R is what? R is 1 minus term number minus 1. R will be always term number minus 1. If it's fifth term, R will be 4. If it is 17th term, R will be 16. Always one number lesser than your term number. That thing will represent your value of R over here. Okay? Now, question number 4 of exercise 14.2. Question number 4 of exercise 14.2. Okay, they are giving us 2x minus a whole cube equals to 8x cube minus bx square plus 3 over 2 bx minus a cube. Okay, this is the question given to me, and they are asking for find the value of a and find the value of b. Okay, this is the question given to me, and they are asking for that I have to find the value of a and value of b. Now, how will I do it? The problem is that I don't know what to do, but I know that if I extend this thing and compare my first term with this one, second term with this one, third term with this one, and fourth term with this one, I will have my answers over here. Okay, so first n is 3, so total terms will be 4. Okay, total terms will be 4, and x is written at first position. Highest power of x is written at first position, and you can see it's written in the descending power of x. Okay, so T1, what will be that? 3C0, 2x, 3 to the power 3 minus 0 minus a whole power 0. Okay, so 3 to the this one, T3, T1 equals to 3C0 will be 1. This will become 3, 8x cube into 1. Final answer will be 8x cube. Okay, T2, 3C1, 2x, 3 minus 1 minus a whole power 1. Okay, Simplifying it, T2 equals to 3C1 will be 3. Okay. Then this will become 3 minus 1 will be 2, and simplifying it will become 4x square into minus 8. When I will simplify it further, 3 4s are 12 minus sign ax square. Okay. T3 3C2 2x 3 minus 2, then minus a whole square. T3 3C2 will be equals to 3. 3 minus 2 will be 1. So this will become 2x and this will become a square. Simplifying it, 6a square x. Last one, T4. T4 will be what? 3C3 2x 3 minus 3 and then minus a cube. Simplifying it, T4 equals to 1, 2 cube means 8, x cube and minus a cube. So now when I'm going to simplify this thing over here, this will become minus 8a cube. Minus 8a cube. Okay. So this is my first term, second term, third term, and this is my fourth term which I have got after expansion. Okay. Now what I'm going to do, I'm going to compare. I'm going to compare to get the value of A and B which is needed over here. So comparing terms. So T1 over here it is 8x cube and over here also it is 8x cube. So nothing can be done over here. I have left it like this. First term from here, first term of here, it's left like this. Okay. Now second term. What is that? Minus bx square minus 12ax square. Okay. X square and x square will be cancelled. Minus b equals to minus 12a or 12a minus b equals to 0. That I have got. Comparison of term 1, comparison of term 2. Now coming to term 3. What's written over here? 3 over 2 bx. Term 3. What is written over here? 6a square x. Okay. So again x and x will be cancelled. This will become 3 over 2b equals to 6a square. Okay. So now if I take it from this one, what will happen? The value of b will be equals to 12a. If I have shifted minus b over here, b will be equals to 12a. So this 12a, I am plotting it over here. So 3 over 2 into 12a equals to 6a square. Okay, simplifying it, 2 1s are 2, 2 4, 2 6 are 12, and 3 6 are 18. A equals to 6a square. Okay, shifting 18a over here. So 6a square minus 18a equals to 0. Okay, after this, what I have done? Simplifying it over here. So 6a common, a minus 3 equals to 0. So value of A will be either 0 or value of A will be equals to 3. They have said that we need non-zero values. So this will not be considered, only this value will be considered when I'm going to plot it over here. B equals to 12 into 3 and that will become 36 in this answer. Okay, so the value of B is coming 36, value of A is coming 3. That's your final answer for this part.